Today I'd like to take a look at sampling distributions. So please turn in your study guide to the sampling distributions section. Now let's begin by talking about parameters. A parameter basically is a number that describes a population. Symbols that we use for parameters include the following. Notice the parameter values are usually indicated by a Greek letter. The letter mu represents the mean of a population. Sigma represents the standard deviation of our population. Lowercase p represents a population proportion. Alpha represents the y-intercept of a least squares regression line. Beta represents the slope of the least squares regression line. And the capital letter N represents the population size. So when we're using parameter values once again are values that basically describe a population. If we were able to do a complete census and then break down these possible values for our population, we would get these parameter values. And we would represent these parameter values with the letters denoted for our parameters themselves: mu, sigma, p, alpha, beta, and capital N. So once again, parameters are values or numbers that describe a population. Now a statistic, on the other hand, is a number that can be computed from sample data without making use of any known parameter values. So if we don't know everything about a population, we may want to try to get an idea of the population by using some statistic summaries. And to get statistics, we're basically using a sample, and hopefully that sample is representative of the population. Symbols that we use for statistics are x bar, which represents the mean, lowercase s, which represents the standard deviation of our sample, p hat represents the sample proportion, a represents the y-intercept of the least squares regression line of the sample, b represents the slope of the least squares regression line of the sample, and lowercase n represents sample size. So once again, statistics are basically numbers that are computed from sample data. If we do not know how to do a complete census of the population, or if it's not possible, we typically take representative samples of the population and come up with values that are called statistics. Identify the boldface values as being either a parameter or a statistic. So in our example here, it says a carload lot of ball bearings has a mean diameter of 2.5003 centimeters. This is within the specifications for acceptance of the lot by the purchaser. Now, by chance, an inspector chooses 100 bearings from the lot that have a mean diameter of 2.5009 centimeters. Because this is outside the specified limits, the lot is mistakenly rejected. Okay, so once again, we're talking about two different means here, and we have to take a look at the context of the problem to see if the actual mean value came from the population itself or from a sample. And notice here that 2.5003 represents a parameter value. The parameter value came from the carload lot of bearings, which was the actual true population. And so we didn't have to go through all those ball bearings on a carload lot. We basically took a sample of 100 bearings that had a mean value of 2.5009. So that value represents a statistic. So the mean mu of 2.5003 represents a parameter value from the population, and the value of x bar equals 2.5009 represents the mean value of the sample data of 100 bearings taken from that carload lot of ball bearings, a representative sample, and so that is a statistic value. Why do we sample? Why do we take samples instead of doing a complete census? Recall the facts earlier that we talked about a census. First of all, a census is not always accurate. A census is difficult or sometimes impossible to do. And finally, a census is very expensive to do. Now, it would be nice if we were able to conduct a census on any information that we're trying to come up with about a population.